Bismillahirrahmanirrahim. Uh, MIS students, this is our last lecture for the semester, and in the previous lecture we covered chapter number 4. We did the revision of the complete chapter number 4, and in this lecture we'll try to cover the chapter number 5. So since it is a revision lecture, I'll be going through the things quickly, quickly. So try to just be with me. So let's start with the this chapter number 5. Uh, the, the topics that were covered in chapter number 5 consisted of components of IT infrastructure, eras of IT infrastructure, technology drivers of IT infrastructure, contemporary hardware platform trends, and contemporary software platform trends. So these were the 5 topics that we covered in this chapter. Starting with the components of IT infrastructure, we discussed this thing that the IT infrastructure is defined as the shared technology resources that provide the platform for the firm's specific information system applications. And now, IT infrastructure include investment in hardware, software, and services, such as consulting, education, and training, that are shared across the entire firm or across entire business units in the firm. So here we can see that IT infrastructure is a very broad terms. It not only covers the software and hardware part, but it include the services part as well. And the services include consulting, like what kind of IT infrastructure is required for what kind of firm. So that whole study that is to be conducted, and then obviously someone has to provide consultation for that. Then educating the people, educating the staff regarding the use of the information technology, that the technology that the firm is using, how it can help the staff in increasing their efficiency and productivity, and then training the employees on using that technology. So this is very broader term. IT infrastructure consists of a set of physical devices and software applications that are required to operate the entire enterprise. But IT infrastructure is also a set of firm-wide services budgeted by management and comprising both human and technical capabilities. So based on this definition, we can see that IT infrastructure is a very broad term, and it includes the following. First of all, for IT infrastructure, we need a computing platform, which include large mainframe, mid-range computers, desktop and laptop computers, and mobile handheld devices. So that is something new addition to this IT infrastructure, these mobile devices. Then IT infrastructure include telecommunication services, because we need to share the data, we need to share the voice and video, we want to provide voice and video connectivity to the employees, customers, and suppliers. For that we need telecommunication services, so that are part of this IT infrastructure. The third thing that is required for IT infrastructure is data management services, because the data is increasing. We discussed earlier in the or in this chapter we'll discuss these different technology drivers. So one of the technology driver is that the data is increasing at an exponential speed, but luckily the cost of storing data is also decreasing proportionally. So it is becoming possible for the firms to store that data. So there's a whole lot of data regarding the firm's operation, customer, employees, and each and every aspect of the business is stored in digital form. For that, obviously data storage capability is required, and then the capability for analyzing that data should be there. So these are included in this data management services. The fourth component of IT infrastructure is application software services. So different application softwares are developed. For example, we are using office products for desktop productivity. Then we need different kind of softwares for if we want to maintain the customer relationship management. For that, the application softwares are available in the market. Similarly, for supply chain management, knowledge management, these type of bundled softwares, or what we call off-the-shelf softwares, are available. So application software is the fourth component. Then fifth component is physical facilities. Now, physical facilities management services are required because whatever computing setup we have, telecommunication setup we have, and data management service we have, that will be physically installed somewhere. So maintain that physical installation is part of this IT infrastructure. The sixth component is IT management services. IT management services plan and develop the infrastructure, coordinate with the business units for IT services, manage accounting for the IT expenditure, and provide project management services. So these are the specific tasks which are related to this IT management services. Number seven component is IT standard services. The technology, information technology is based on certain standards. The standards are required for compatibility. The standards are required because for large scale usage, if certain standard is adopted, it results in economies of scale. So IT standard services provide the firm and its business units with policies that determine which information technology will be used, when, and how. The eighth component of IT infrastructure is IT education services. As I discussed earlier, that training is part of it. Once we have installed certain information technology, once we are using when a company is using certain information technology, the employees need to be trained so that they can get full advantage from that. So that is what IT education services is doing, that it provides training in system use to employees and offer managers training in how to plan for and manage IT investments. And the last but not the least, ninth component of IT research and development is ninth component of IT infrastructure is R&D. So research and development is very important because it provides the firm with research on potential future IT projects and investments that could help the firm differentiate itself in the marketplace. So these nine components that we discussed, they are all part of this IT infrastructure that the firm is using. Now moving to the second topic of chapter number 5 is eras of IT infrastructure. The IT infrastructure in organization today is an outgrowth of over 50 years of evolution in computing platforms. There have been 5 stages in this evolution, each representing a different configuration of computing power and infrastructure elements. So this evolution of IT infrastructure can be divided into 5 eras. So the starting point can be traced back to these 5 eras are general purpose mainframe and computer computing. Number 2, personal computers. Number 3, client server networks. Number 4, enterprise computing. Number 5, cloud and mobile computing. So the start of IT infrastructure can be traced back to 1959 when these general purpose mainframe computers they came to light. The introduction of the IBM 1401 and 7090 transistorized machines in 1959 marked the beginning of widespread commercial use of mainframe computers. Now, in 1965, the mainframe computer truly came into its own with the introduction of IBM 360 series. The 360 was the first commercial computer with a powerful operating system that could provide time sharing, multitasking, and virtual memory in more advanced models. So, although this era started in 1959, but this era became more, prominent. The main, you can say, hallmark of this era was the introduction of 360 series of mainframe computers introduced by IBM, and then obviously IBM dominated mainframe computing from this point on. Mainframe computers became powerful enough to support thousands of online remote terminals connected to the centralized mainframe using proprietary communication protocols and proprietary data lines. The mainframe era was a period of highly centralized computing under the control of professional programmers and system operators, with most elements of infrastructure provided by a single vendor, the manufacturer of the hardware and the software. So these were the main characteristics of this mainframe era. that the computing was highly centralized. Mainframes were installed in headquarters uh, or the regional headquarters, and then the centralized processing was being done there, and it was done under the control of professional programmers and system operators. So that was another feature that was that was common to this mainframe uh, era. And the third thing was that this whole mainframe computing was controlled, or it was managed by a single vendor who was the manufacturer of the hardware and the software. Now, this pattern began to change with the introduction of mini computer produced by DEC Corporation, which is Digital Equipment Corporation, in 1965. DEC mini computers, the popular models were PDP-11 and later the VEX machines, offered powerful machines at far lower prices than IBM mainframes, making possible decentralized computing customized to the specific needs of individual departments or business units rather than time sharing on a single huge mainframe. In recent years, the mini computers have evolved into a mid-range computer or mid-range server and is part of a network. So the mainframe computers, they truly came into its own with the introduction of IBM 360 series, whereas the mini computer, they became popular with the introduction of uh, the mini computers produced by DEC Corporation. And both years were the same, 1965. The main reason for popularity of mini computers were that they were less costly and obviously less powerful compared to mainframe, but because of because mini computers can be used for decentralized computing, they became popular rather than using one giant mainframe computer. The companies they preferred using several mini computers to serve the need of each of their department or each of their regional head offices. So that is why these mini computers, they became popular. The second era of IT infrastructure was the introduction of personal computers. And then although the first truly personal computers appeared in 1970s, which were the Xerox Alto, the MITS Altair 8800, and the Apple 1 and 2, to name a few. These machines had only limited distribution to computer enthusiasts. The appearance of the IBM PC in 1981 is usually considered the beginning of the PC era because this machine was the first to be widely adopted by American businesses. Right, so 1981, why we are taking this year as the starting of this personal computing era? Because that was the year when IBM introduced its PC, and that was widely adopted by the American businesses. Then uh, at first, the disk operating system, DOS, a text-based command language, was used as the operating system, and then it was later replaced by Microsoft Windows operating system. The Wintel PC computer became the standard. Wintel stands for Windows operating system used in a combination with the Intel processor. So that became the standard desktop personal computer. Today, 95% of the world's estimated 1.5 billion computers use the Wintel standards. Proliferation of PCs in the 80s and early 90s launched a spat of personal desktop productivity software tools, word processors, spreadsheets, electronic presentation software, and small data management programs that were very valuable to both home and corporate users. These PCs were standalone systems until PC operating system software in the 90s made it possible to link them into networks. So that was basically a step ahead, further step in the IT infrastructure, that these personal computers, they became popular and widely adopted by the businesses as well as the domestic users. The third era of IT infrastructure was this client server era, which was basically which can be traced back to 1983. In client-server computing, desktop or laptop computers called clients are networked to powerful server computers that provide the client computers with a variety of services and capabilities. Computer processing is split between these two types of machines. The client is the user point of entry, whereas the server typically processes and stores shared data, serves up web pages, or manage network activities. So here you can see the idea behind client server computing. The client basically is used by the users. It is mostly used for data entry, or it can be used, it is mostly used for retrieving the reports, but all the processing or the storage of the data or the web pages, the content that serves up the web pages, they are all stored on these, they are all conducted by means of the server. The term server refers to both the software application and the physical computer on which this network software runs, right? So server is not only the hardware part of it, but server is also covering the software component of this client server architecture. The server could be a mainframe, but today server computers typically are more powerful versions of personal computers based on inexpensive chips and often using multiple processors in a single computer box. So we see today nowadays dual core, quad core, these type of processors. So since we can have multiple processors, and so we don't need you know uh, mainframes. Rather, these personal computers have become powerful enough to serve as a mainframe to serve the same functionality as that of the mainframe computers. The simplest client-server network consists of a client computer networked to a server computer with processing split between the two types of machine. This is called two-tiered client-server model. In two-tier client-server model, there is one server and it is serving the different clients, whereas simple client-server networks can be found in small businesses. Most corporations have more complex multi-tiered, which is often called n-tier client-server architectures, in which the work of the entire network is balanced over several different levels of servers depending on the kind of service being requested. So in n-tier client-server architecture, we have multiple servers, more than one server. That is why it is called n-tier or multi-tiered architecture. For instance, at the first level, a web server will serve a web page to a client in response to a request for service. Web server software is responsible for locating and managing stored web pages. If the client requests access to a corporate system, a product list, or price information, for instance, the request is passed along to an application server. Application server software handles all application operations between a user and an organization's back-end business systems. The application server may reside on the same computer as the web server or its own dedicated computer. So here we can see the example of multi-tier architecture, that we have more than one server. We have a web server software and then we have a application server software. So two servers, they are handling two different types of requests. The web server software is handling the request for web content, whereas the application server software is handling all the application operations between a user and an organization's back-end business system. Client-server computing enables businesses to distribute computing work across a series of smaller, inexpensive machines that cost much less than mini computers or centralized mainframe systems. The result is an explosion in computing power and applications throughout the firm. Novel NetWare was the leading technology for client-server networking at the beginning of the client-server era. Today, Microsoft is the market leader with its Windows operating systems, which include Windows servers, Windows 7, Windows Vista, and Windows XP. Okay, so moving ahead with the eras of IT infrastructure, evolution of IT infrastructure, the fourth important achievement or fourth important landmark was the enterprise computing era. This era started in early 90s when the firms turned to networking standards and software tools that could integrate disparate networks and applications throughout the firm into an enterprise-wide infrastructure. As the internet developed into a trusted communications environment after 1995, businesses began seriously using the TCP/IP, which stand for Transmission Control Protocol and Internet Protocol networking standard to tie their disparate network together. Now, the idea behind enterprise communication was that we don't need to have different software serving the different units or different purposes of the business. Rather, we need to have one software addressing the need of the entire business units. So the resulting IT infrastructure linked different pieces of computer hardware and smaller networks into an enterprise-wide network so that information can flow freely across the organization and between the firms and other organizations. It can link different types of computer hardware, including mainframes, servers, PCs, mobile phones, and other handheld devices, and it includes public infrastructure such as the telephone system, the internet, and the public network services. The enterprise infrastructure also requires software to link disparate applications and enable data to flow freely among different parts of the business, such as enterprise application and web services. So basically, that was a very a great achievement for large-scale businesses. The development of these enterprise systems, they solved their problem of linking disparate units into one single system, and that data was freely shared. It means it was available, that it can flow freely across the organization and between the firm and other organizations as well. Okay, so the latest era of IT infrastructure, 2000 to present, it started, or it can be coined as cloud and mobile computing era. The growing bandwidth power of the internet has pushed the client server model one step further towards what is called the client computing model. Cloud computing, cloud computing model, cloud computing refers to a model of computing that provides access to a shared pool of computing resources over a network of the internet. So what is the idea behind cloud computing is that whoever is in need of using any, like he requires storage space, if a customer is interested in getting access to different applications, or if he wants a development platform, software development platform, all of these services can be provided to that client using the internet. So this is the idea behind cloud computing. These clouds of computing resources can be accessed on as needed basis from any connected device and location. Currently, cloud computing is the fastest growing form of computing, with global revenue expected to reach close to $89 billion in 2011 and nearly $149 billion by 2014, according to Gartner Incorporation technology consultants. Thousands or even hundreds of thousands of computers are located in cloud data centers where they can be accessed by desktop computers, laptop computers, netbooks, entertainment centers, mobile devices, and other client machines linked to the internet, with both personal and corporate computing increasingly moving to mobile platforms. IBM, HP, Dell, and Amazon operate huge scalable cloud computing centers that provide computing power, data storage, and high-speed internet connection to firms that want to maintain their IT infrastructure remotely. So some firms have become expert in this technology, which include IBM, HP, Dell, and Amazon. And since with the expertise they have gained, what they are doing now, that they are providing these services to other people as well, so to other companies as well. So software firms such as Google, Microsoft, SAP, Oracle, and Salesforce.com sell software application as service delivered over the internet. So we have the firms available if who provide computing power and data storage, whereas there are firms available on the net which provide the software services as well. Okay, so that was our part one of the lecture. I think I took a little more time here. I'll try to be little faster on other parts because we have to cover different components, different parts of this lecture. So moving on to the part two of this lecture. In part two, we covered uh, technology drivers of IT infrastructure, and in that we discussed these five main technology drivers. I will give you an overview of these five here. Moore's law and microprocessing power. Moore's law is basically that the computing power is increasing exponentially. So the power of computing, according to this uh, Gordon Moore, according to Gordon Moore, this computing power is increasing exponentially, and that was the finding that he, after conducting the research on microprocessor chips, he came up with this finding, and basically uh, later on, uh, different people interpreted this Moore's law in different ways. For example, these three interpretations are commonly found. Number one, the power of microprocessors double every 18 months. Number two, computing power doubles every 18 months. And number three, the price of computing falls by half every 18 months. So these are something which basically are based on this Moore's law. So Moore's law was mostly related to the computing power. The second that we covered was the second technology driver was the law of mass digital storage. According to this law, the cost of data storage is decreasing, exponentially. The number of megabytes that can be stored on the magnetic media for $1 from 1950 to the present roughly doubled every 15 months. So in 2012, a 500 gigabyte hard drive, hard disk drive sells at a retail for about $60. The third technology driver was Metcalfe's law and network economics. Metcalfe's law basically applies uh, to the network, the power of the network. Metcalfe and other points to the increasing returns to scale that network members receive as more and more people join the network. So as the number of members in a network grows linearly, the value of the entire system grows exponentially and continues to grow forever as member increase. So that was basically what the Robert Metcalfe pointed out uh, in 1970. The fourth technology driver, declining communication cost and the internet. So this is the fourth technology driver that is transforming the IT infrastructure, and the exponential declining cost of communication both over the internet and over telephone networks. As communication costs fall toward a very small number and approach zero, utilization of communication and computing facilities explode. So that is one of the reason why the information technology is becoming ever more popular, because of this declining cost of the internet and uh, of and telecommunication. To take advantage of the business value associated with the internet, firms must greatly expand their internet connections, including wireless connectivity, and greatly expand the power of their client-server networks, desktop clients, and mobile computing devices. There is every reason to believe this trend will continue. And the fifth technology driver is standards and network effects. Now, technology standards are specifications that establish the compatibility of products and the ability to communicate in a network. So as standards are developed, more and more firms adopt those standards, and then the technology, that is following that standard is widely adopted by the consumers, and as a result of it, this network effects creates as generated that we discussed earlier in Metcalfe law, and economies of scale, they are enjoyed by the network members. So these economies of scale are important, because without these economies of scale, computing of any sort would be far more expensive than is currently the case. Some of the standards we discussed, which include ASCII standard, COBOL, Unix, TCP/IP protocol, Ethernet, IBM Microsoft PC, which is Wintel combination, and then World Wide Web. These are some of the important standards in computing which are adopted worldwide. Okay, so the third topic, rather fourth topic of chapter number 5 was this contemporary hardware trends, and in that we covered these 8 trends that included mobile digital platform, number 2 consumerization of IT, number 3 grid computing, number 4 virtualization, number 5 cloud computing, number 6 green computing, number 7 high performance power saving processors, number 8 autonomic computing. So I'll try to go over these one by one. So rather I'll give you an overview. Mobile digital platform is the contemporary hardware trend. Why? Because the mobile devices are becoming more popular. Nowadays, mobile devices sales have surpassed the sale of the desktop technology, and because of the widespread adoption of these mobile devices, this platform is becoming very popular, and it is now even used in it is commercially being adopted. The firms uh, the new mobile platform includes small lightweight netbooks optimized for wireless communication and internet access, tablet computers such as the iPad, and digital ebook readers such as Amazon's Kindle with web access capabilities. Okay, so the second contemporary hardware trend is that of consumerization of IT and bring your own device. Here, the idea behind consumerization of IT is that once certain technology or certain software is widely adopted by the public, it ultimately makes its road into the commercial, front as well. So there are many technologies we see that they were used by public first, and then they were adopted by the businesses. Example can be that of the social networking tools, Facebook, Twitter. All of these, they were used by the public for social networking, but later on the businesses realized that they can also be used for business purposes as well, and they were adopted by the businesses. The idea behind bring your own device is that an employee might be using a laptop, or he might be using a netbook, and he might be very comfortable with it, so he might be allowed to use it for commercial purpose as well. So it means now that technology is dictated by the users and not by the IT consultants anymore. Previously, before, the trend was that the IT consultants, they used to decide what kind of technology should the firm use, but now it is dictated by the consumers. That is why this technology trend is named as consumerization of IT. So that was the end of part 2 of this lecture. Let's move to the part 3. So uh, quickly, okay, this is the lecture, chapter 5, part number 3. Let's see what we covered in this. Obviously, we are discussing the contemporary hardware infrastructure. So in this lecture, we covered 3 hardware infrastructure structures: grid computing, virtualization, cloud computing. The grid computing involves connecting geographically remote computers into a single network to create a virtual supercomputer by combining the computational power of all computers on the grid. So the idea behind grid computing is that we combine, or uh, we combine the computational power of different computers who are at different geographical locations, and we link them together to make it a virtual supercomputer. The Why this grid computing is important? Because it was observed that the computer systems that are used by the individuals or it is used by the firms, 25% of it is used for the work, and remaining they are sitting idle. So then this idea came that why not to use this idle time, like when the computer, no processing is done on these computers, why not to utilize that time as well. So this was the idea that gave birth to this grid computing. Grid computing was impossible until high-speed internet connections were enabled, and the business case for grid computing involves cost saving, speed of computation, and agility. An example of this is Royal Dutch Shell Group using a scalable grid computing platform that improves the accuracy and speed of its scientific modeling application to find the best oil reservoirs. This platform links 1024 IBM servers running Linux, in effect creates one of the largest commercial Linux supercomputers in the world. Moving to the fourth contemporary hardware trend is virtualization. Virtualization is the process of presenting a set of computing resources such as computing power or data storage so that they can all be accessed in ways that are not restricted by physical configuration or geographic location. So this concept of virtualization is somehow is little bit, or it is somewhat related to uh, the grid computing. Here again, what we are doing that we are linking different data sources to appear as one large data source, or we are linking different computers, processors of different processors of different computers to appear as one supercomputer. So virtualization enables a single physical resource such as a server or storage device to appear to the user as multiple logical resources. So this can be one to many, and then we can have many to one as well, that there are different computers, there are different this data storage is at different locations, but to the user it appears that this whole data is stored at one location. Virtualization also enables multiple physical resources to appear as a single logical resource, as would be the case with storage area networks or grid computing. Virtualization makes it possible for a company to handle its computer processing and storage using computer resources housed in remote locations. Okay, then the next one was cloud computing. Cloud computing we already discussed earlier as well. Here we are discussing the definition of cloud computing, which is given by NIST, which is United States National Institute of Standard and Technology. So according to NIST, cloud computing has the following 5 characteristics. Number 1, on-demand self-service. Number 2, ubiquitous network access. Number 3, location-independent resource pooling. Number 4, rapid elasticity. And number 5, measured service. There are 3 computing models: cloud infrastructure as a service, cloud platform as a service, cloud software as a service. And then we discussed the 2 types of clouds. One is the public cloud and the other is private cloud. Public cloud is owned and maintained by cloud service providers such as Amazon Web Services and made available to the general public or industry group. Whereas a private cloud is operated solely for an organization. It may be managed by the organization or a third party and may exist on premises or off premises. So public cloud is public, it is owned by the company, but it is available to the public, whereas private cloud is owned by an organization, or it might be owned by a third party, but it is only available to a particular organization. That is why it is called private cloud. And then we can have a hybrid cloud as well. Certain activities, hybrid cloud computing model is where company uses their own infrastructure and for their most essential core activities, and adopt public cloud computing for less critical systems or for additional processing capacity during peak business periods. So that was the end of part 3. Now quickly move on to part 4 of the lecture. So here is uh, part 4, chapter 5, and part 4 of this chapter 5. And thus in this we covered the remaining 3, total 8 contemporary hardware infrastructures were covered, and 5 we have already covered. The last remaining 3 are these: green computing, high power and power saving processors, and autonomic computing. The idea behind green computing is to protect the environment. So the computer should be designed in a way that their parts can be recycled, or they can be easily disposed of without damaging the environment. Similarly, the power consumption by the computer should be minimized so that it does the power consumption is minimized, and as a result, the power whatever the negative impact on the environment is created by the generation of electricity or power, it is minimized. So that is the idea behind green computing. Then we have high performance and power saving processors. This is another way to reduce power requirements and hardware sprawl, is to use more efficient and power saving processors. Contemporary microprocessors now feature multiple processor cores on a single chip. For example, we have uh, uh, we can find the pieces in the market with dual core, quad core, 6 core, and 8 core processors. So these different, this way the computing power is increased of a computer, and then instead of using many computers, we can use one single computer for uh, performing multiple tasks. So the power consumption is reduced, as well as the number of devices is reduced, which ultimately results in the this is uh, green. This is also helpful for achieving the objective of green computing as well. Then autonomic computing, the idea behind autonomic computing is that the computer systems should self-optimize themselves, self-tune themselves, heal themselves when broken, and protect themselves from outside intruders and self-destruction. The example of autonomic computing can be these of antivirus softwares, that as soon as any virus attack is there, they automatically detect the virus activity, quarantine that virus, and then clean the PC from that virus activity. So everything is done automatically, and that is the idea behind autonomic computing, that computing without human interference, it is built in. So IBM and other vendors are starting to build autonomic features into products for large systems. That was the end of part 4. So let's move on to the part 5, and I think this part 5 should be the no, we have 2 more lectures in this. The the part 5 and part 6 of this chapter of these series of lecture covers the contemporary software trends. In contemporary software trends, we covered Linux and open source software, and then we covered Java, HTML, and HTML5. So open source software is a software produced by a community of several 100,000 programmers around the world. So open source software is by definition not restricted to any specific operating system or hardware technology, although most open source software is currently based on Linux or Unix operating system. Now, the idea behind open source software is that it is developed by hundreds and thousands of programmers, so obviously it can be expected that the software produced would be of commercial quality. Now we can see different popular software software tools which are based on this open source technology, which include Linux operating system, the Apache HTTP web server, Mozilla Firefox web browser, and the Apache OpenOffice desktop productivity suite. One example of open source software is Linux, and this is perhaps the most well-known open source software. It was created by Finnish programmer Linus Torvalds, and it was first posted on internet in August 1991. Linux applications are embedded in cell phones, smartphones, netbooks, and consumer electronics. Linux is available in free versions downloadable from the internet or in low-cost commercial versions that include tools and support from vendors such as Red Hat. Although Linux is not used in many desktop systems, it is a major force in local area network, web servers, and high-performance computing work. So, most commonly, it is the most commonly used software in LAN, which is local area networks, and web servers, as well as high performance computing work. IBM, HP, Intel, Dell, and Oracle have made Linux a central part of their offerings to corporations. The rise of open source software, particularly Linux and the applications it supports, has profound implications for corporate software platforms, cost reduction, reliability, and resilience, and integration because Linux works on all the major hardware platforms from mainframes to servers to clients. And then the second contemporary software trend is that of software for the web. Java. Java is an operating system independent, processor independent, object oriented programming language that has become the leading interactive environment for the web. The Java platform has migrated into cell phones, smartphones, automobiles, music players, game machines, and finally into set-top cable television systems serving interactive content and pay-per-view services. Oracle Corporation estimate that 3 billion devices are running Java. So the main advantage of Java is that it is operating system independent and it is platform independent. HTML is a page description. HTML, hypertext markup language, is a page description language for specifying how text, graphics, video, and sounds are placed on a web page and for creating dynamic links to other web pages and objects. So HTML was originally designed to create and link static documents composed largely of text. Today, however, the web is much more social and interactive, and many web pages have multimedia elements which include images, audio, and video. So for that purpose, we need third-party plugin application like Flash, Silverlight, and Java to integrate these rich media with web pages. Now, the next revolution of HTML, called HTML5, it solved the problem which were there with the HTML, because HTML was designed for static display, and as we discussed that for dynamic content, for audio-visual content, the HTML was using third-party plugins. So this problem was solved because HTML5 made it possible to embed images, audio, video, and other elements directly into a document without processor-intensive add-ons. HTML5 also make it easier for web pages to function across different display services. So it automatically, a document which is prepared on HTML5, it automatically detects the type of the device the user is using, and it automatically formats the document according to the display available to the user. So that is main advantage of HTML5. The differences between HTML and HTML5. HTML5 provides better support for different types of media. HTML5 enables JavaScript to run in the browser. HTML5 introduced brand new input attributes. HTML5 has a better browser compatibility than HTML. HTML5 now makes it a lot easier to find locations, and HTML provides native support for vector graphics. So that was the end of part 5 of this chapter 5. Now moving to the last lecture related to this chapter number 6, and in this part 6 we covered again contemporary software trends, and we covered two trends in this part: web services and service oriented architecture, and software outsourcing and cloud services. Web services refer to a set of loosely coupled software components that exchange information with each other using universal web communication standards and languages. They can exchange information between two different systems regardless of the operating system or programming languages on which the systems are based. So basically you can say they are these web services are a middle or interpreter for the different systems. They are a middle layer which is used. So the foundation technology for web services is XML, which stands for Extensible Markup Language. It was developed in 1996 by the World Wide Web Consortium, and it is developed as a more powerful and flexible markup language than HTML. XML has the ability of describing the data. So any number which is there in which is a number in case of HTML, it is not a number in case of XML. Rather, it can be specified. We can put a tag with that number, that what this number specify. So different kind of tags can be put there. For example, the number can be a price, it can be a date, or it can be a zip code. So by tagging selected elements of the content of documents for their meanings, XML makes it possible for computers to manipulate and interpret their data automatically and perform operations on the data without human intervention. Virtually all major software vendors provide tools and entire platform for building and integrating software applications using web services. IBM includes web service tools in its WebSphere, and similarly Microsoft has incorporated web services tool in its Microsoft.NET platform. An example how these web services are used: the web services, they are linking different sources of data in together, like data which is coming from an airline company, and that data which is coming from tour operators. Then there is a travel reservation system, wireless website. All of these are they are providing data which is collected by these web services, and ultimately this data is transferred to the server, and then it is transferred to the information system which is used by the company. So this web services is, as I told you, is a middle layer. It is a interpreter for the system which is used by the company. And the second trend is outsourcing and cloud services. So we can see here that many business firms continue to operate legacy systems that continue to meet a business need, and that would be extremely costly to replace, but they will purchase or rent most of their new software application from external sources. So that is the idea. There are three external sources of software. Number one, software packages from commercial software vendor. Number two, outsourcing custom application development to an external vendor. And number three, cloud-based software services and tools. So we have software packages which are pre-written commercially available set of software programs, and that eliminate the need for a firm to write its own software. Enterprise application software vendors such as SAP and Oracle, PeopleSoft have developed powerful software packages that can support the primary business processes. Then software outsourcing enables a firm to contract to contract custom software development or maintenance of existing legacy programs to outside firms, which often operate offshore in low wage areas. And then we have the third, which is cloud-based system. So cloud-based software and data is and the data it uses are hosted on powerful servers in data centers and can be accessed with an internet connection and standard web browser. So instead of buying and installing software program, subscribing companies rent the same functions from these services, with users paying either on a subscription or per transaction basis. In order to manage the relationship with an outsourcer or technology service provider, firms need a contract that includes a service level agreement, which is called SLA. The SLA is a formal contract between customers and their service providers, and it defines the specific responsibility of the service provider and the level of service expected by the customer. Okay, so the software you use for both personal and business takes tasks today may be composed of interchangeable components and integrate freely with other applications on the internet. Individual users and entire companies mix and match these software components to create their own customized application and to share information with others. The resulting software applications are mashup. So mashup is a tool, is a is an application, you can say, which is developed by integrating data from different sources. So you can develop different apps, business apps, by combining data. For example, a business app might be showing data, integrating data from a stock market. It can be getting data from the from the commodities market. It can be integrating data from the website of the state bank or the central bank. So similar so the data which is required by the business managers, all of that is integrated in one application, and that idea is that of mashup. Similarly, apps which we can find on Google Store or which we can download from the Apple uh, App Store, Google Play and App Store. These apps are small, specialized software programs and are designed for mobile devices like smartphones and tablets. The use of apps now exceed the use of mobile browsers, which are much slower and cumbersome for accessing mobile software. With this, we come to the conclusion of chapter number 5. So in one lecture, I covered the whole series of lectures that were related to these chapter 5. So these lectures are available on the web, as well as you have the slides available with you, and you can go over these, and still, if you have any queries or any questions, you can ask on the Google Classroom, or you can post them on the WhatsApp group. So with this, I conclude my today's lecture. Thank you very much for being with me. God bless you. Allah Hafiz.